Hi, today I was specifically to talk about just continue with the previous note. So what do we have before is just one site, but right now they're split to different sites and it's all development. So previously it's just natural area, it's like a grass, forest, those kind of things. Right now it's development, so it's pavement. So you'll see every catchment they have more impervious surface right now. So the percentage of the impervious surface are different. Okay, and but the Mannis number coefficient are the same. Infiltration model is still keep the same, doesn't change. So I think the only thing changed is slope and well, the width definitely changed. But I will specifically talk about how to calculate the width. All right, because we talked about last time if there's multiple lines, right? Um, you add them together. But this case, I just want to clarify that this might not be the right thing to do. Okay, so this thing we just don't consider this that much. Okay, I will let me just draw. So just look at this one. Okay, that's good. But when we look at the development in here, you will find out like so this is all by lot. So area lot they actually is the single drainage line. Okay, so basically this whole land is all changed by those small overflows. Okay, but each overflow to only contour these small areas. Okay, like a lot. Okay, like your properties. Okay, so we did have this water flow, but it's only contour this small area. So which means it's a one subcatchment, but the water flow is this mini catchment. Okay, so basically you could simplify this with all this area become two three big area. Okay, like here, so just like here, three big area, this one, this two, this three. Okay, and they all have the same length of overflow. Okay, so you just use this as overflow. Okay, so this becomes the flow length. Okay, so you only have one flow length. So instead of so previously is this long, but right now it's only just one piece of it, just this long. Okay, because of development. Just remember that. Okay, and then we use the area to minus this. Okay. The same way with this. This is a little bit different. Is it's kind of complex. You have this area, so all the water is flow this way, and this area kind of the same length flow this way. But like in this area, the water will flow like this. Okay, so there's two parts. How we deal with that is you want to calculate the overflow by the area they control. Okay, for example, like this one, they just control this much area. So you will see here, this is the total area, this is how much they control, and then it's like 60%, I guess, for both these two area. So 60% of the length of this one, and then the other percent is the length of this one. Okay, so it's like weight. Okay, um, what I call so this is what we call the weight summed overflow path. Okay, so it's based on the average um, the area you control. Okay, the same with this one. Okay, um, so just remember this, really important. Okay, because sometimes your catchment that we have is not actually a single catchment. You have some mini catchment. Okay, so just remember that. So this is how they calculate all the widths. Okay, in all these areas. Okay, it has been changed. Um, But again, all the water will flow to this outflow. Okay, if I just run it, and this is just 2 years um, intensity, and you will find a totally different results. So the results is they will give all the subcatchment results. Okay, and you will find out this one they have no runoff. The reason is it's all natural. Okay, and if you open up S7, you will find out the impervious surface is 0. Okay, and the pervious surface Manning's number is pretty high, so they all the infiltration is really good. Okay, infiltrate a lot, but all here they didn't infiltrate that much. Well, S3 is kind of in between. See here, S3 is like half, so it's like this. But if you look at the outfall, let's just delete this one. Like click the outfall and add it. Let's add the total inflow, and let's just click OK, and you will see we have a lot more inflow. Okay, a lot runoff. It's like 45. Okay, in previous video I think if I'm right, we just have 30 or 7. So there's way more. How many times? It's like 5 times more in terms of inflow. Okay, that's how big difference it was. Okay, so I just open this up. This is the previous area. It's all natural, and you can see the catchment. Let me see the catchment. So impervious surface only 5%, so not much. And look at it's only 4 cubic feet per second. Okay, but if you look at this one, I mean, it's a lot. On this one, let's go back. So it's 45, 10 times. Okay, that's the difference. All right. So just to let you know, so this is just an example of how they calculate the width, and also how it works with multiple catchment. Okay, we can have multiple catchment and all connected with as long as they all connect with the same outlet, you can calculate. And the other thing is you want to make sure if there's one catchment, actually we have a catchment here. If like for example, so when you do a model, you better, for example, this catchment, they draw it, but it's not included. Okay, so you just make sure all the catchment they eventually all flow to the same outfall. Okay, just make sure it's under a big watershed. Okay, you don't want to have a catchment, the water just flow somewhere else. Right, that's not that's not useful. You don't have to model it. Right. So the reason we need this is we try to model the pressure of area where it can easily get flooded. Right. So that's this. I'll see you next time.